Fast radio bursts, or FRBs, are intense, brief pulses of radio waves that originate billions of light years away. Since their discovery in 2001, astronomers have been trying to figure out what they are and where they come from. And while thousands of these bursts have been found, figuring out their exact location in space has proven difficult, making it hard to narrow down the possible sources. But that hasn't stopped astronomers from using them to study the universe. For some time, their potential to help weigh the matter between galaxies has been evident to astronomers. That's because when these bursts are beamed in our direction, they can pass through the gas and dust of the universe, allowing us to study the intergalactic medium, or the matter between galaxies. To act as a gauge of this matter, though, the energy burst has to have a localized point of origin with a known distance from our planet. And thus far, astronomers have only managed to perform this localization for about 100 FRBs. In a new paper published today in the journal Nature, a team of astronomers led by Natasha Hurley-Walker, a professor at Curtin University's John Curtin School of Medical Research, used a technique that has allowed them to localize 69 FRBs to use them as probes of the universe. The FRB with the maximum distance that the team was able to localize, FRB 202305 to 1b, is the most distant FRB source ever discovered? But how do you find the distance to something that far away? The answer lies in a type of star called a supernova. When a massive star dies, it often explodes into a supernova. These supernovas release a huge amount of energy and matter into space and leave behind a glowing cloud of debris. As this debris expands, it causes the light from distant supernovae to appear dimmer and redder than expected. This dimming effect allows astronomers to measure the speed at which the supernova is receding from us, which can then be used to calculate its distance. When an FRB is detected, astronomers can use this same technique if they can see a supernova in the same part of the sky at the same time. The researchers were able to localize their 69 FRBs using data collected by the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, telescope. CHIME is a large radio telescope that is designed to measure the distribution of hydrogen gas in the universe. It is a perfect instrument for detecting FRBs since they are only a few minutes long. The telescope is located in British Columbia, Canada, and consists of 150-meter radio telescope arrays distributed along a 500-meter baseline. The team used a technique called dispersion, which takes advantage of the fact that lower-frequency radio waves move through the interstellar medium at different speeds depending on the density of the matter between the galaxy and the observer. By measuring the change in frequency, astronomers can determine the amount of matter the signal has passed through, which allows them to weigh the material between the galaxies. Using this technique, the team was able to measure the amount of matter between our galaxy and the 69 FRBs they studied, which allowed them to map the distribution of matter in the universe over a large fraction of the sky. They also found that the amount of matter they measured agrees with that predicted by the Standard Model of Cosmology, which is good news since it means that our models of the universe are still holding up. But the team hopes to do more than just confirm existing models. In a statement, Hurley-Walker said that they are working on using these fast radio bursts to test modified theories of gravity, alternative models of dark energy, and the effects of cosmic strings. Cosmic strings are hypothetical one-dimensional defects in spacetime that could have been produced in the early universe. If they exist, they would have a significant impact on the way that matter moves through the universe. In a paper published last month in the monthly notices of the Royal Astronomical Society, Hurley-Walker and her team proposed that the next generation of square-kilometer array radio telescopes will be able to detect the tiny distortions in the cosmic microwave background caused by cosmic strings. They are also hopeful that their new distance measurements will allow them to study FRB sources in greater detail. FRBs are still a relatively new discovery in astronomy, but they are already providing scientists with a wealth of information about the universe. As our technology improves, we can expect to learn even more about these mysterious bursts and the role they play in the cosmos. This research was supported in part by the Australian Research Council, the National Science Foundation, and the Gordon and Betty Moore Foundation. If you liked this video, check out our other videos about the universe. And if you love the science and text stories that we tell, you can find more on our website. Thanks for watching.